Can you get 20 Hz with small sealed subwoofer? I got the questions from my channel subscribers, and simple answer is yes. But this topic is by far more complicated than you think. Let's take a look how this question has been asked. With your knowledge, does it interest you to do some videos on subwoofer amplification? With DSP and subwoofer drivers, there is a lot talks about you need 1000 of watts, especially for a small sealed enclosure, and producing the lowest notes. I run my subwoofers 100 watts to excursion limits at 15 Hz. Seems impossible with the current thinking. Then I gave some basic answer, and then it's the same. I only have my limited experience and parts. I built a 19-liter box. It's a small box with 10-inch subwoofer, and asked to go down to 15 Hz. Asked for advice on the forums how many power I needed, and my finding was in contradiction to common knowledge as far as I know. In this topic we will go a little bit deeper in a theory, and also we will look at the good small subwoofer examples. It's not a simple task, and there is a lot of engineering thinking in it. And there is another guy +1 to this request. It would be very interested to see something like this covered in this channel. And here you have some optimistic text. Now it's time to be a DI subwoofer builder. DSP are easy to get. Put a driver in a sealed box and you have a subwoofer. A power amp is a choice now. My logic is to play Cinewave of the lowest frequency, intend to play 15 Hz. Jesus, 15 Hz. This only works for sealed. And if my amp can force my drivers to excursion over a bit of time, it's good to go. There are some hopes in this text, and we should cover some theoretical basics also to understand why this task is so difficult, especially about the 15 Hz. We don't hear it, but 15 Hz, even 20 is super challenging, super challenging. To show that topic is not that simple as you may think at beginning, here is a small subwoofer woofer, and you can see a lot of complexity. This design can go down to 11 Hz at ±3 decibels. And pay attention, 1 kilowatt power, you have DSP, those are small drivers, 6.5 inch, dual drivers. And dimensions are, I'm not living in inches, it's about 25 by 25 by 25 centimeters. It's like a basketball ball, probably. You can see that to make it cost effective and utilize magnets, there are 3 large magnets, and they use both drivers use the same magnet. You can see that voice calls, one is going inside, one outside. And then you can build some kind of design for 11 Hz at 3 dB. But don't forget about this 1 kilowatt. Small design and 1 kilowatt. Here I took one professional amplifier board, which really can do 600 plus 600 watt RMS. So we're still talking about a 1 kilowatt plus, and this board can drive any normal subwoofer. At least for home cinema it will be perfect. But you can see it's pretty big board. The power supply switching mode transformer is capable of roughly estimate about 4 kilowatts probably. It's a really powerful MOSFETs here and powerful MOSFETs here. Decently built board, but when you need a power, it's challenging. Let's look to some of really good subwoofers. What's the best subwoofers for 2023? And let's try to find out some similarities. There are several subwoofers picked, and best overall subwoofer, very good price, relatively small power, but a large driver size. It's not very small, but it's for a budget and got decent reviews. There is another one, very cheap, but generally speaking, it definitely can go down to 20 Hertz. Then let's look at the high-end subwoofer, those who can do first wattage, 800 watts RMS, it's a lot, and driver size 2 times 12-inch woofers. Since it has 2 woofers, it has a higher sensitivity, therefore also a little bit lower amplifier power. But anyway, 800 watt RMS. Another solution, again, 12-inch woofer, 700 watt RMS, relatively expensive, generally seems the same. And then is our small, it's your target, what you want to build. A small subwoofer with a deep bass, KEF KC62, $1,500 USD, kilowatt amp, 2 specialized drivers, side firing, a lot of good words said about it. This fits in our design, small subwoofer. And now let's look at the manufacturer site. Here is more descriptions. You can see that this subwoofer is kind of the same size as a football ball, a little bit larger. There is mentioned technology, power. It's driven by actually 2 power amplifiers, each of the 500 watts. Remember, you need a power. This company producing 2 subwoofers. One is this small one, and one is the larger one. And what is the difference? 6-inch and 9-inch drivers, the same power amplifier. And this is important. Actually, for subwoofer to really hear it, you need to play it very loud. You need a maximum SPL as high as possible. This one is capable of 105, remember this figure, and this can play almost twice louder. But you can see dimensions are different, and smaller ones, of course, has a lower efficiency. It would be wise to go for higher efficiency. Both of them can play very low. It's kind of optimistic room size, 5 to 50 square meters. I don't believe that the small one could play in a 50 square meters room. I would say 5 to 20 square meters room. And this one, maybe at 50 square meters, maybe. So we at least found some subwoofer, small size, what can go down to 11 Hertz. Impressive. One thing what we should understand, those equal loudness charts, what they represent different frequencies, what you subjectively perceive as an equal loudness. And typically we are listening our home cinema between 60, it's a level of our speech, up to 90, and then we have some peaks in a movies what goes up to 110 even. But normal listening volume is about between 60 and 80. For music mixing is done around 80. That if you listen music at that loudness, you don't need to use tone controls to hear precise music reproduction. For home cinema, dynamic ranges is higher. But let's look at 60. For example, you are listening your movie at relatively calm and low level. To get to 60 in a mid-range, you need about 1 watt, approximately, even less. Your speaker sensitivities are given with 1 watt, probably you get even at 90. It's a half watt here. Okay, let's take a 60 dB. It's a relatively low level home cinema listening. And the mid-range, it's 60 decibels. To hear the same at 20 Hertz here, you need 100 decibels. Here you at 60, and you need 40 decibels more to hear it in the same loudness. You need tons of power just to start to hear. And for example, if you put lower power at the same level as you are listening that movie, you are below hearing threshold. Your speaker is moving, but 20 Hz you can't hear. You barely start to hear adding 20 decibels more. This is important to understand why you need so huge power. Huge power. Our hearing sensitivity is fundamentally different. And you can see if you want to have a balanced low frequencies and middle frequencies for home cinema listening relatively loud, that your woofer at 20 Hz, it demands 110 dB SPL. And when we looked at those subwoofer specs, the smallest one is able to go only for 105. So there is no way that you can, with a small subwoofer, can listen balanced home cinema at 20 Hz. But probably it's absolutely fine about 30 and 40. But at 20 Hz, it's extremely difficult. This our low hearing sensitivity plus low efficiency of the woofer demands tons of power. So the one conclusion what we can make, you can't make a small subwoofer with 100-watt amplifier. You need 10 times more, almost kilowatt. And remember that sound is not speaker movement. Sound is speaker acceleration. Only acceleration creates a sound. With 100-watt amplifier, you can move speaker. Yeah, you can visually see how it is moving. It's no sound. Only this invisible sharp movement, sharp acceleration gives SPL. Okay, there is another good solution, similar what we already looked at the KEF, 3000 micro. And what engineers is writing. The challenge of designing mini subwoofer capable of chest pounding output at the lowest frequency while maintaining effective thermal and energy management in micro-sized enclosures has always been the holy grail of subwoofer brands. Previous designs were flawed with a weak output distortion and uncontrolled movement of the cabinet itself. So it's a difficult task. And 3000 micro is like a magic trick, small enough to fit anywhere in a capable of delivery breaking bus from a shocking compact 10-inch enclosure. For the first time ever, micro subwoofer does not compromises on performance. And then we can see what is the cost for that. SVS engineers had to bend the laws of physics designing micro-sized subwoofer capable of massive, pristine output in hi-fi and home theater systems. Reference amplifier technology from the flagship SVS 16 Ultra subwoofer has applied in 800 watts RMS and 2.5 kilowatts watt peak power sledge with discrete MOSFETs, outputs of effortless on-demand current with an urging control. Crazy! 2.5 kilowatts, remember. And let's understand what peak power does mean. Also, probably you have heard about the Crest factor. Here is Texas Instruments white paper. It's a trustable source. So what we will look, and let's look to the Crest factor. Okay. Let's read a little bit this document. It is valuable to understand the details here. Typically, the maximum power supply of Class D amplifiers is around 50 volts to stay below dangerous voltage level without the need for special insulation and protection. With 50 volts supply voltage in BTL mode, the peak power is 156 watts on 16 ohms impedance and 625 watts on 4 ohm impedance. In most cases, subwoofers are 4 ohm impedance, or even there are 2 ohm impedance subwoofers. We need a lot of power. But the peak power is only one parameter of an audio amplifier. Another important parameter is the continuous RMS power capability. So we have peak power and RMS, or is this what is related to temperature. Amplifier should be capable to deliver peak power. It should be built in a way that peak power he can deliver without a problems. Both parameters are connected by the crest factor, figure 11. It shows crest factor visually. Let's make it larger. If you look at the details, what do we see? We see that average power, what we are listening, is relatively small. This is typical music. You have kicks and drums, what are with a high level, and then average is pretty low. Typically, if you have 100-watt amplifier, your average RMS power, what you are playing is 1/8 of that, 10-15 watts. With very compressed music, maybe 1/4. When we calculate amplifiers, we are using this 1/4 ratio. If you look at mathematics or in the formulas, the crest factor is either specified as a ratio or in decibels. For example, here you can see this is a peaks ratio to RMS. And here is a mistaken formula, I don't know why, but if you want to express it in decibels, then this part is correct. Why they put, I don't know, those two. This is mistake in a document. And if you look further for different musics, that ambient noise has relatively low crest factor, only 10 decibels. Speech, it's 4 times, 12 decibels. Music with peak levels and compression from 4 to 8 ratio. As I mentioned, uncompressed music or 50s, 60s, 80s produced music has 8, and today we are capable to compress a lot, and then we have a ratio of 4, those 12 to 18 decibels. Music without peak level compression at all could go up to ratio 10, and movie audio, it's more than 10, more than 20 decibels. What does it mean? Typically, when we are listening music, it's kind of high dynamic range. When there is a calm dialogues, it's fine, and when your blood-sucking predator is jumping, then your windows are shaking. So, and your wife come in and say that if you don't put it lower level, the kids are sleeping, then you will have trouble. So when you design a power amplifier, first you design average power for power supplies, average current capability, thermal interfaces, component packages, RMS parameters of magnetic components. This is all about overheating. And peak power supply defines peak current capabilities, what could be 10 times higher. Current limit, that your protection circuits in kick, saturation current of PFC and output inductor. So you will go with a huge current, and it's much higher than you probably calculate. And peak current capabilities of FETs and diodes and other stuff. So there are 2 parameters, RMS and the peak power. And definitely you need a rail voltage what is capable to deliver it. What do we see here? This is heat dispatch, and this is a real amplifier wattage. Yes, you can't run it for a long time, but at least typically for minute you can run 2 kilowatts. Could you imagine requirements for subwoofer amplifier? Practically you need professional grade amplifier. Most of subwoofer amplifiers are done in a bridged amplifier configuration to reduce rail voltage. Another thing to consider, since you have very, very high power amplifier, you have a heat inside of those drivers. And let's make a small calculation. Typically those are copper wires. We take a copper wire temperature coefficient, or original resistivity. Okay, we have 4 ohm speaker, original temperature 25 degrees, and final temperature 155, Y155. Here is enamel wire, and it's meant to operate up to 155 degrees as a normal. So let's go to resistivity and final resistivity, calculate, bam, we have 6 ohm speaker. What conclusions can we make when we are making so powerful systems? Anyway, the coil temperature is going up, that instead of 4 ohm speaker we have 6 ohm speakers, and we are losing 1/3 of power. So higher ohms, lower current, our SPL is going down. And what happens if we're going to marginally high, for example to 300 degrees Celsius still can operate, because copper is melting on 1000 degrees of Celsius. So we're adding more power, and we're getting 8 ohms internal resistance of woofer. So we are adding more power but not getting more sound pressure. So this also is one alternative if you need higher SPL or louder. It's better to go for 2 woofer solutions, or I don't know, use a larger, higher efficiency loudspeakers. There is no way that you can go with an amplifier up and up and up. Okay, this was kind of warm-up, and one thing what we recognize when we are going to the small type of woofers, we need a lot of power. And going up with the power is challenging, and I included some theory in our story. You can skip it, but I encourage to follow. I know my English is not super fluent, but anyway, I will try to explain that basics. It will answer a lot of questions about power amplifier, SPL, what kind of speakers and woofers you should choose, why it's important, that speaker efficiency and other stuff. I will use educational document, not written by me but by respectable scientists. I will go through this document step by step and do comments. But it's important to understand there's a key relationship between amplifier power and audio loudness, what you hear, or SPL. One thing we already covered, it's about equal loudness curves. You can read a little bit more about that, but the key meaning is that our air sensitivity is different for mid-range frequencies and for low frequencies. Here is technical article, and written by Matthew Birdsworth, probably one of the easiest and the best technical articles about the topic of amplifier power versus speaker efficiency, or the first watt is the loudest. So, typical question all the time, I have speaker XYZ, how much amplifier power do I need? And actually this question comes down to a couple of considerations. How efficient are your speakers? What is the size of your room, and how loud do you typically listen? And factors what determines amplifier power or needed amplifier power, that's the speaker efficiency. Speaker efficiency is simple. It describes how loud a speaker plays for a given input power and at the given distance. It's measured in SPL, sound pressure level, in decibels, dB, typically at 1 watt of input power and at 1 meter distance from the speaker. This is industry agreed standard. It's agreed. It's not like specific physical meanings. Industry agreed that to have a common language, we decide certain measurement standards. For example, 88 decibels at 1 watt, 1 meter. So, speakers which are more efficient will transmit more sound into air, higher SPL, sound pressure level, for a given input power. Second, the distance from the speaker is listed in the measurement, because for every doubling of the distance from the source, the sound pressure level reduces by 6 decibels. 6 decibels is a lot. 1 meter is a standard, so different speakers can be easily compared. So remember that we have number of factors. One is a distance, how far we are listening. So for common language, that sound pressure level is set in decibels in a logarithmic ratio. And here is a formula. It's correct formula. From equation above, the measurement sound pressure level is divided by a reference sound pressure level to get a ratio. The value of this ratio is compared in decibels. So what is a reference? Important. What is a reference? SPL reference is a value of 20 micropascals, which corresponds to pressure wave in air at the threshold of human audibility. So at 1 kilohertz, it's here. It's somewhere here, those 20 micropascals. Our hearing threshold is even lower than this 20 micropascals. That frequency is about 3 kilohertz. We can hear even better, but industry standard is here. Here is 20 micropascals. This is hearing threshold. Even there is a sound for a human, it's absolute silence. Absolute silence. Yeah. No, clearly, therefore we compare a speaker's pressure capability to lowest sound pressure that human can hear. Well, it's logical. This reference was found through acoustic studies, averaging the hearing characteristics of large number of participants. So scientists did a lot of experiments, and then they set that 20 micropascal level. The second important parameter is room size. When we studied subwoofer parameters, there was mentioned for how big room the subwoofer has been developed. And roughly saying about 50 square meters and 100 square meters. Room size matters because a larger room requires more sound to fill it. I described it previously. Regardless of the speaker, SPL drops by 6 dB every time the distance of the speaker doubles. Very important. Very important. This is true for both the distance to your walls or boundary of the sound and the distance to your listening position. And now I want to draw your attention, because it's critically important. This one sentence is absolutely critically important. How loud you listen. If you play loud, then you need more amplifier power than someone who plays music much quieter. Acoustic studies have found that approximately 10 dB SPL increase is perceived as twice as loud by our ears. Remember this 10 dB SPL increase. 10 dB SPL increase. Third one, super important. Amplifier output power versus SPL. Considering modern room sizes and moderate listening levels, speaker efficiency will be the largest factor in determining the required amplifier power. For every doubling of amplifier power, a speaker can produce 3 dB more SPL. And now, with doubling amplifier power, and let's come back, to hear twice as loud, we need 10 dB. Now, for example, if you have 96 decibel efficient speakers, those are very efficient, almost professional or a professional, and currently use 1 watt amplifier, increasing to 2 watt amplifier will make the same speaker produce 99 dBs. Since speaker efficiency is rated with 1 watt of input power, the 99 dBs would be the maximum SPL the speaker is capable at 1 meter distance with a 2 watt amplifier. With a 100 watt amplifier, 100 watt more power, the speaker will be capable of 20 dB more SPL than 1 watt case, for an output of 116 decibels at 1 meter. And if we double 100 watts, if the amplifier power were then increased to 200 watt, the apparent gain in SPL would gain only 3 dB. Or we can get from 116 decibels to 190 decibels. It will not be twice louder, it will be a bit louder. Nice, this time it took plus 100 watts to only gain 3 decibels. And we came to very important conclusions that sound pressure versus amplifier power is a logarithmic relationship. Inversely stated amplifier power must be exponential to SPL to increase by a constant amount. And in this moment we came to kind of point that generally speaking it is pointless to build very small subwoofer and use huge power. It's much easier to build a little bit larger subwoofer and use significantly less power. Actually in figure 1, this is a figure 1, the gain in speaker SPL versus amplifier power ratio is plotted. Notice that for increasing amplifier power, SPL increases at a slower and slower rate. This is a problem with amplifier power. It takes exponentially more power to continue to increase SPL. Again, small size subwoofer problem. Now, using figure 1, if we increase our amplifier power by 10 times, we gain 10 dB SPL. However, it takes 100 times amplifier power, another power of 10, to gain 20 dB SPL. It is for this reason that the higher speaker efficiency requires exponentially lower amplifier power to drive them to normal listening volume. If you want to play loud or are running out of amplifier headroom, the best solution is to get more efficient speakers. Again, the answer for those small subwoofer lovers. Theoretically, it's a bad approach. It's a bad approach. Adding more amplifier power is fighting a losing battle. Yeah, you need more efficient solution. More efficient solution means a larger size subwoofer, larger size woofers, dual woofers, etc. Let's look to some practical subwoofer speakers. Dayton Audio reference subwoofer, 8 ohms, expensive, 300 euros. And let's look to the datasheet, and you can see not very sensitive, 85 decibels. There are all those small and type parameters. You can put in some calculator and find out the box for that. But what I want to draw your attention that between 50 Hz and 20 Hz, the only 5 decibel drop. With that woofer, you definitely can go down to 20 Hz. You can do some DSP compensation, yes, and get it back and flat to 20 Hz. It is 400 watts rated, RMS, and you remember the Crest factor, 4 times. We can give a 1.5 kilowatt amp and get all necessary parameters. We can build very good subwoofer with this one. And if you go for something very small size, there is some kind of crazy subwoofer, 6-inch, let's say. Look at the datasheet. And you can see that how much drops sensitivity on a 20 Hz. It's already 12 decibels, Sensitivity probably is low. Yes, very low sensitivity. Okay, relatively high power. You can do something with that, but anyway, it's better to use a larger subwoofer and you will get a much better result. So that's a very short kind of theoretical thinking about a small size subwoofers and what conclusions we can make. Is it possible to build? Yes. Is it high-tech? Absolutely. Look at the complexity of that great subwoofer design. Do you need a power? Sure, you need a lot of power for a small subwoofer to drive it in the same way as a larger one. Do you need a powerful amplifier? Yes, it's important. You can use some industrial or professional amplifiers. Also, our human sensitivity, or human hearing sensitivity at low frequencies is far less than in medium frequencies or middle frequencies. This also asks for a lot of power. And the last one, it's far better to build a higher sensitivity system than just raise amplifier power and try to make it very small. But generally speaking, yes, today you can make a small subwoofer, but it is difficult and it is expensive. And the last thing to remember that SPL increase versus amplifier power ratio is exponential, and it's better to go for more sensitive speakers than for a higher power.